So for this problem, we are supposed to be working with a truth table with conjunctions, disjunctions, and conditional statements. And so we're again going to use that feature where we add additional columns. And to do that, you click that little add column button within ALEKS. I'm just going to draw these by hand just so we can practice what that would look like. So first of all, I'm going to recopy P and Q and the truth values there, just starting with T, T, F, F, and then T, F, T, F. That gives us all the different options there. And as I look at this, I have a couple things that I notice. Here's the thing we're trying to figure out. We've got P implies Q, so that's the conditional, and we've also got not P. So when I look at these kinds of problems, I'd like to do the simple things first. I'm going to figure out the not P, because we're going to need that. And then, so the negation of P, sometimes I find not P and not Q right away just to get those out of the way. Some people like to do these in order and do what's in the parentheses first, and so figure out that conditional. So it wouldn't be wrong for your additional column to be the conditional P implies Q. So you may have done it that way, and that's just fine. It doesn't really make any difference. So we've got not P, so I'm going to do the negation of P. So that's F, F, T, T. So I'm just looking at P and negating it. So that's just the opposite of whatever you saw in this first column. And then I also need the conditional statement P implies Q. So we need to add a column for that. And so the conditional P implies Q. And these are things we need to have committed to memory. That when they're both true, then that's true. So P implies Q. What I'm doing is I'm looking at these first two columns now. P implies Q. So I'm looking only at the first two columns to make this decision. True implies false. That is false. And then false implies true. That's actually true. And false implies false. That's actually true. So for the conditional, remember that it's only false when the second statement is false. And so then finally, I'm ready to do the whole thing. And so now that's P implies Q, or not P. So now I'm ready for the entire statement. The reason I can tell I'm ready for the entire statement is as I look at this, I'll go back to my yellow highlighter here. As I look at this, I really have two pieces to this or. So there's my or. I've got the P implies Q, or not P. And I apologize, I think I said or. I meant and, because that's a conjunction, not a disjunction. But at any rate, so the and, P implies Q, and not P, that statement, if you remember, is, let's go back to the pen, that statement is true only if both statements are true. So I'm looking at, using the highlighter, I'm looking at this column and this column. So those are my only two columns I'm looking at to evaluate this. So if it was a conditional, I'd have to keep track of the order, but it's just the and, the conjunction. So I'm going to go back to my pen here and say, remember that conjunction is only true if both of these are true. So here I've got the first row, one of them is false, so it's false. Here they're both false, so it's false. They're both true, so it's true. Both true, so true. So there is the overall truth value for that truth table. So that's essentially your final answer is what we're saying. So again, as you make these, the key is adding extra columns. The key is building those columns one at a time until you have all the pieces of your overall statement, and then you can consider what you need to consider to evaluate the truth table for the overall statement. And when you do it that way, it keeps them fairly straightforward, fairly easy.